All right, so continuing on with the process, our goal at this point would be to merge these two so that we can at least solve for one of the variables in terms of x and y, because those are the things that we could get from the original data set. So we have this b equation solved in terms of, among other things, a. So what I can do is duplicate this. And let me just clean things up a little bit, but that can go. I'm going to replace that a with what I know it now is. It ain't going to be pretty, but it's something. All right, now, if all goes to plan, we should be able to do something with this. All right, so we want to make it a little friendlier. So let's start by distributing this individual to each of these two terms. So I'm going to do a lot of duplication here and then just smidgen things over. Probably could have taken the b along for the ride. In the end, that's the least of my worries, I guess. So we're going to be multiplying the sum of x by the sum of y. So let me smidge this over. I'll just snag this sum of x here and duplicate it. Could probably afford to bring this over a little bit more. And then bring the whole thing over. We're going to need some more length on that fraction bar, but that's okay. I also need to multiply that sum of x by another sum of x. So it's a sum of x as a quantity squared. All right, and we'll get to that in a second because we could do something a little bit nicer with that too. Let me do this and this. All right. It also kind of serves a purpose, more than kind of, I should say. It serves a purpose to get a common denominator. And put these two parts of the numerator together. All right, so more duplication coming your way. Probably don't need all of this. I don't know if that 2 is going to make it. Oh, it made it. Okay, made the cut. All right, so this is now part of that. This is now the overall denominator, or part of it anyway. Now, this little guy down here is really, and you know what, before I reference that little guy down there that nobody knows what I'm talking about, I'll put it over a 1. So this little guy down here is a prime candidate for a little keep change flip action. So I'm going to take advantage of that opportunity. This time I'm not going to try to be too cute here. I'm just going to pop it right in. The sum of x sub I squared. All right. So that looks a lot nicer, I suppose. Problem is, I got a b in there. All right, and that kind of it's kind of an issue, right? Because we have an expression defined in terms of itself, so I have to take care of that. Can't just have that lying around. So b equals b equals. So now I could do a little cross multiplication. So we're looking at n times b, sum from I equals 1 to n of x sub I squared equals all of this stuff. All right, so we're just cross multiplying. I think I accidentally took that fraction bar along with me, but we'll see. Yep, we can get rid of that. All right. So I'm going to add this expression to both sides. And you see we have a common b that can be factored out, so that's what we're going to do all on the fly here. We're going to say b times n, the sum from I equals 1 to n of x sub I squared minus the sum from I equals 1 to n of x sub I squared. Now that x sub I squared is, again, it's not the x sub I that's squared, it's the sum of x sub I that's squared, so it's the whole thing. All right, so that's actually a nicer sum of x sub I squared, because what that is the x sub I values all added up and then squared, which is generally an easier calculation. That's what I was kind of alluding to before. Then, I'm just cleaning this up a little bit. Then squaring each value, that's what the other one is. Squaring each value and then adding them all up, right? So then this is all equal to everything on the other side except for that last little bit that I got rid of. Let me get that equal sign along for the ride too. All right, and so then it's a matter of division. Ooh, look what we have down, yeah. I'll get to that in a sec. So b is equal to, oh, let me put the b over here, all of this stuff on the right hand side. Now you look at the model that you have down there, the least squares regression b sub o plus b sub 1 x sub I. Now we tend to use, I'll make a little note, we use y hat is equal to a plus bx. All right, so it looks like what we're trying to, what we were trying to figure out and what we ended up finding out is this. All right, it's just in a very, very trimmed down form, but you can see we have, I'm just kind of bring along for the ride here. Here's an n, here's an n. xy, xy, oops, I lost it. Ooh, hello plus sign. Where did you come from? Well, that is the question, isn't it? we have a magic plus sign that appeared most likely right, oh, you gotta love it when this happens, right here. Distributor property robbed me of my aha moment. I hate when that happens. So, which makes this a root, which makes this a root, which makes this root. Just making sure that I copied the right thing. I did not. It's this one. Which makes this, this, and this, 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 and this. And that becomes a that, and a that, and a that, become a that, and a that, and back in the game. All right, minus, minus, okay, good. X, sum of x, sum of y, n, sum of x squared, n, sum of x squared, minus sum of x, you know, the other sum of x squared. All right, so that's good stuff, you know, eventually. But we got there. All right, so that's the first part of, well, it's not really the first part, but it's one of two equations that we had to derive, so here we are. All right, so now what we need to go back and do is get the B sub O value. All right, we just figured out the B sub 1. Oh, the B sub 1, I mislabeled, apologies. Oh, the snowball effect, in case anybody was wondering. This should have been a B. Oh, yeah, we're really doing great now. All right, so anyway, the whole world is judging me for that. That's all right, I'm immune. So let me shrink down so I could have a little bit more space to be able to produce the other part of the solution, which I will do in the next video.